Alright, today we're going to talk about quadratic functions. A polynomial function is a function in this form, and I know this looks crazy and gibberish, but we're going to break it down so that you can understand what this means. It says where these are just real numbers, and n is greater than or equal to 1, and it's a natural number, and the domain of all polynomial functions is negative infinity to positive infinity. This is an important concept. Okay, the natural number n is called the degree of the polynomial if. Okay, basically what we're going to do is we're going to break this down, and the first term is called the leading term. This term right here, it's going to be the leading term of the polynomial. The a sub n part of it is the leading coefficient. The a sub 0 part, the very number at the end, is going to be the constant term. And we're going to talk about the degree of 0 and what a degree of no degree looks like. So what I'm going to do is I'm going to bring you to this table. Let me move this out the way. And so if I have this regular function, f of x, which means the same thing as y equals, f of x equals 2. This is actually just a constant function. The degree of this function is 0 because it does not have a variable with an exponent. So the degree is 0. The leading term there's only one term in it, so it's 2, and the leading coefficient in this case is just 2. Let's look at the next one. In this polynomial function, 5x minus 1, this is actually a linear function. The degree is the exponent of the variable. So x is to the first power, so the degree is going to be 1. The degree of this term is 1. The degree of this term is 0, so we use the higher of the two. Okay, so we have our leading term is 5x, and so the leading coefficient, the coefficient's the number in front of the variable, is just 5. Okay, when we look at this, we go find the term that has the highest exponent, and that's going to be the degree of our polynomial. So this one is an x squared, so the degree is 2. The leading term is going to be the term with the highest exponent in it, and the leading coefficient is going to be the 4. And this is actually a quadratic function because it's an x squared. The name of this function would be a cubic function because the highest exponent in it is to the third power. So we have the degree is going to be 3, and our leading term, the term with the highest exponent, is going to be 2x to the third, and the leading coefficient is going to be 2. And we have our last one. It's a quartic function. Now you have to be careful because these are all listed. The highest term, the leading term, is actually not in the front like it's been in all the previous ones. So if this was written in descendant order, it would be, but it's our job to go through and find this term, the leading term, and say, okay, the degree of this one is going to be degree 4. It's a 4th degree polynomial. The leading term meaning the term with the highest exponent, is going to be the variable with the highest exponent. It's going to be 3x to the 4th, and then the coefficient, the leading coefficient of that term, is just going to be a 3. Okay, so that's a little bit better description of what we talked about over here. This is just including all numbers and variables, and it's a little bit easier to determine leading term, leading coefficient, our constant term, and our degree when we look at some concrete examples. Now, we did not name the constant terms in this chart, so let's go back and do that. The constant term is just going to be 2. It's the number at the end with no variable, basically. So if I came up here and I said constant, because we left that off, the constant term we said was 2. The constant term in this one is going to be negative 1. Constant term in this one is positive 1. The constant term in this polynomial is 5 and 5 once again. So in this one it's also going to be 5. So we talked about the degree, the leading term in the polynomial, the leading coefficient, which is from your leading term, and then the constant's going to be the number without a variable. Okay, so that's kind of the description of what we talked about here, just some of our properties of quadratic functions. Okay, now we're going to go into a little bit more detail about the f of x equals ax squared plus bx plus c, where just a, b, and c are some real numbers. So we have a number here, a number here, and a number here, as long as a is not equal to 0. When you have a quadratic function, it's an x squared function, and it's going to have the graph of a parabola. This is our parent graph, which is f of x equals x squared, and the vertex is 0, 0, so pretend this dotted line is exactly over this. It's hard to graph it, and I wanted you to be able to see, but this dashed line is actually going to be exactly over this solid black line. The axis of symmetry is always the x value of whatever your vertex is. So your vertex is 0, 0. Axis of symmetry is the equation x equals 0. Okay, domain is going to be, let me remind you, your domain is all of your x values, leftmost to rightmost, so from negative infinity to positive infinity. Your range is going to be your y values, and it's the bottommost to the top. So as I get it here and I start at the bottom, my function doesn't start until 0, and then it goes all the way up in both directions, so 0 to infinity. And I'll make you a little note that the domain is going to be the x values of your function, the range is going to be the y values, and the domain has to be written left to right, and the range, the y values, have to be written from bottom to top, and it has to be in that order or it's going to be named incorrectly. Next, we're going to get into graphing quadratic functions, and these are just some characteristics about functions that we're going to talk about. And like I said, when we start seeing examples of these things, they'll start to make more sense, but we're going to talk about the definition. First of all, your vertex is going to be your HK, which is basically, it comes from here and here. And this a value, whatever this a value is, all it means is if it's positive, if this is positive, it's going to be a parabola that opens up. Okay? If this a value is some negative number, it just means it's going to be a parabola that opens down. So basically, the sign of this, whether it's positive or negative, tells us if it opens up or down. Okay? The value of this tells us if our graph is going to be left or right, if it's shifted to the left or to the right. If it's greater than 0, it's going to be to the right. If it's less than 0, it's going to be to the left. This tells us if our graph was shifted up or down, positive for up, negative for down. And so don't get caught up in all the technicality of this if this confuses you. Like I said, when we put some numbers in here and we break it down, it should be able to clear it up for you and make things a little bit more realistic.